Okay, we're ready for worksheet 8B. Yeah, I loaded these pictures because I was reminded of a story. One time I went down to the state line between North and South Carolina, the little river down there, and I had taken my son and I had gone on an all-day fishing trip out into international waters, and I've mentioned with some classes that with the fact that there are state laws governing gambling, that, there are some businesses that will take you on a boat out to international waters and then you can gamble to your heart's content. That's 12 miles off the coast. And this is one such boat that I believe was chartered out of the little river, and it had a dock right next to ours, where we were coming and going from our fishing trip. And I remember the afternoon that we got back from the fishing trip, and we were waiting for the first mate to clean all of the fish and load it up into a cooler so we could take it home with us. And as we were sitting there, the dock for this boat pulled up next to us, and all the people started, and there are probably 100 people on the boat. And I have never seen in my life such sour faces. They must have taken them to the cleaners. I remember hearing one guy commenting to another one. He's saying, "You got any money for gas money?" And the other one looks at him and says, "I was going to ask you." So, I really wasn't kidding about the idea of having a certain amount fixed in your mind when you walk into that situation. If I lose this much, I'm done. I can't go any further. And apparently they did not listen to that voice, and they were very sorry for it. Anyway, all right, moving on with more of real life. Cadbert estimates there's a 65 chance he will make 70,000 and 35% chance he will lose 30,000 in a business venture. So we have to, we'll call it win and lose. If he wins, if he loses, there is a 60% or 65% chance that he will win and a 35% chance that he will lose. He will make 70,000 this way, and he will lose 30,000 that way. So once again, I'm going to tap pause to do the calculations. Okay, so our expected value here is 45.5, and there's negative 10.5. When we add them together, we still get 35,000. So I would say that that is a pretty good expected value. Okay. Phil Bertina is a star player for UNC Women's. She injured her ankle. Doubtful she will play. If she can play, coach estimates they will score 78. If she doesn't play, they will score 62. Team doctor estimates there is a 60-40 chance she will play. So our outcomes are play or not play. Our probability is 60% chance that she will, 40% chance that she won't. If she does play, they'll score 78. If she doesn't play, they'll score 62. So then we multiply these and add them. Okay, so that is what each of these, so when I add them together, I get 70.71.6. So that is what they are estimated according to the doctor's estimates. If somebody were a betting person, they would go somewhere around 72 points for the game. Okay. Number 3, grass grows half an inch a day on sunny day and a quarter inch a day on a cloudy day. 75% of the days are sunny, 25% are cloudy. Find the expected amount of grass growth. All right, so our two options are sunny and cloudy. 75% of the days are sunny, 25% of the days are cloudy, and we're expecting a half an inch a day on sunny and a quarter of an inch a day. What we're calculating here is the expected amount of grass growth on a typical day. All right, so we add those two together and we get 0.4375. Not quite a half an inch per day. Okay. All right, multiple choice exam is 4 possible answers. For each correct answer, you awarded 5 points. For each incorrect answer, 2 points are subtracted from your score. For answers left blank, no points are added or subtracted. If you do not know the correct answer to a particular question, is it to your advantage to guess? All right, let's look at expected value here. Now we could, there are correct, there's incorrect, and then there is blank. Now, there are 4 possible answers, which means that you have a 25% chance of getting it correct. And 75% chance of it being incorrect. You know, when you think about it, this blank thing is going to turn out to be useless because it really is about these two. You get 5 points, but you lose 2 points if it's incorrect. So that is going to be 1.25. And this is going to be negative 1.5. So your answer is going to be negative 0.25. So, you know, if you are guessing, you actually stand a chance of losing a quarter of a point. So, you know, if it were an option of either doing this or, you know, just leaving it blank, at least if you got 0 points, you didn't have the prospect of losing points. And that's the idea here, is that you have more of a chance of losing points than you do of actually getting it right. Now, this looks like exactly the same problem. I did not mean for that to happen. Yeah, this this is the duplicate, sorry. All right, we're holding a raffle. 1,000 tickets are sold for $5 each. A prize of 500 is to be awarded. If Terry buys 1 ticket, what is his expected value? Well, he could win or he could lose. And so if he if they are selling 1,000 raffle tickets, he has 1 out of 1,000, tens, hundreds, thousands, which means that he has a 0.999 chance of losing. Now, he spent $5 to get in. So if he wins the 500 less the 5 that it costs to get in. But if he loses, all he does is loses $5. So now if I move the decimal place 3 places over, 1, 2, 3, that's what that is going to look like. That I'm going to need a calculator for. All right, so that's what that is going to look like. And when I'm going to wind up with a negative number. It's going to look like that. So his expected value is going to be negative 450. Which I guess you could look at it from this perspective. If he's going to spend $5 to get in, he's got a pretty good chance of losing. All right, they said find the fair price of a ticket. All right, let's do this without the consideration. Get in. Whoops. If I do it this way, so this indicates what our fair price of the ticket would be. If they cost 50 cents a piece, but think about that for a minute. 50 cents times 1,000 tickets is $500. The fair price of the ticket, it means that nobody makes any money at this. You know, everybody buys their ticket and the $500 prize is awarded and there's $0 left over, which doesn't sound like much of a fundraiser to me. But just, you know, sometimes it is good to have a handle on where the fair price is, because that tells you how much, you know, if I'm going to mark this up, if I were to charge $1, that means I'd get $500 left over after I pay out my prize. So you can kind of gauge not only what you think the market will bear, you know, at what point do I jack up the price so much that people stop buying tickets? You know, that's an important question. And so, you know, if I keep the ticket price fairly low, people are more likely to buy into it. And the more I sell and you know, keep the prize money the same, the more I make. That's simple economics. All right. According to the mortality table, which that tells you how long you are expected to live, 60-year-old woman will die within 1 year is 0.05. If she buys a 10,000 one-year term policy for 600, what is North Carolina Mutual's expected gain or loss? All right, so, you know, again, you have two options here. Either she lives or she dies. If she lives, the insurance company has, well, first of all, let's see now, will die within 1 year is 0.05, which means that she has a 0.95 chance of living. Remember, they always have to add up to 100%. Now, if she spends her $600 and lives, then the insurance company gets to keep the $600 and walk away with it. But if she dies, they'll pay out the $10,000 less the $600 they got in payment for it. So that means that they will actually lose $9,400 if she dies. Now let's do the math. All right, so this is what the numbers look like. They'll make $570 this way. They'll lose $470 that way, which is a net gain of $100. So, it depends on how much they need to make to cover their costs, but that sounds like a good deal to me if I were the insurance company. All right, one card from a standard deck of playing cards. You pick a heart, you win 10. If you pick a face card, which is not a heart, you win 8. You pick any other card, you have to pay $6. All right, so if you pick a heart, well, the heart is one suit, which there are 13 cards in each suit. So that's 13 out of 52 chance of you drawing a heart. Now, picking a face card, which is not a heart, you got to stop and think about that. Jack, Queen, King are the face cards. And if you're doing something which is not a heart, there are 3 other suits. There are diamonds and spades and clubs. So that's actually 9 out of the that's going to be 9 out of the 52. As you may recall, at one point we said there were 12 face cards, 3 cards times 4 suits. Well, we're not doing the hearts this time. And then if you pick any other card, let's see now, there's 13 here. There's no overlap here, so there's 22 out of the 52. That means that there are 30 other cards. All right, you win $10 here, you win $8 there, you pay 6 over here. So let's see how that works out on the calculator. Okay, so that's what those numbers are going to look like, and by the time that we add them together, we're going to wind up with a positive 42 cents. So is this a game you want to play? Possibly. You actually stand to win more than you lose. All right. Paying $10 to play the following game of chance. 12 balls, 5 red, 3 green, the rest are yellow. You draw 1 ball from the bag. You win $14 if you draw a red ball, and you will win $12 if you draw a yellow ball. Now, it sounds like you win nothing if you draw a green one. So let's see now. Our options are red and green and yellow. And 5 out of the 12 are red, and 3 out of the 12 are green. And that makes 8 out of 12, which means 4 out of 12 are yellow. Now, you pay 10 to get in. You win 14 for a red ball, which means you come out $4 ahead. For a green one, you lose all of the 10. And then for the yellow ball, you win 12. You paid 10, so that's actually coming out $2 ahead. Now, that is going to be $1.67. That is going to be negative 250. And that is going to be, 8 over 12, which is 2/3, which is about 67 cents. So by the time we add them together, this becomes 234 minus 250, negative 16 cents. And so if you played this 100 times, you would lose, you would lose $16. Yeah, I'm not terribly keen on that game, at least not playing it more than a couple of times. Okay, let me see how many I got to go. All right, I got 4 more to go. All right. 1 in 9 chance of recovering stolen property. His out-of-pocket expenses are going to be $9,000, and he has paid his fee only if. What should he charge his clients in order to break even? So, basically the outcome is find and not find. There's a 1 in 9 chance of finding it, which means he has an 8 in 9 chance of not finding it. Now you're trying to figure out what should he charge. Actually, I'm going to do something here. So if he's going to break even, his out-of-pocket expenses are $9,000. Something does not feel right about this one, because if he charges $8,000, that means he's going to lose money every time. Oh, I get it. Wait a minute. Maybe I get it. All right, I had to back up and think about it this way. If he goes on 9 investigations, he is going to spend $9,000 on each one. That's $81,000. And so if he's going to spend $81,000 on these 9 investigations, then the one that he recovers had better be worth $81,000. Now we got to figure out how to make this work here. So if we are proposing $81,000, then we need to restructure this. And I think this should work out evenly. Now, if he is looking at charging $81,000 and he has $9,000 in expenses for the one that he finds, that's $72,000. Now, if he doesn't find it, he loses $9,000. So this should be $8,000, and this should be negative $8,000, so that when you combine them, they come up with a 0 EV, and that would be break even. So that's us demonstrating why it is breaking even. It doesn't exactly prove how we came up with the 81,000. Like I said, if you're 1 in 9 chance of recovering it, then out of every 9 jobs you do, you're spending $9,000 on each one. That's $81,000 you've spent on 9 jobs, and you only get paid for one. It better be a good one. Better be a good paycheck. All right, let's move on. Slow rider has a probability of 1/20th of coming in first and second and third. First place pays, second and third place. Is it worthwhile to enter the race if it costs $1,000? All right, here we go. We're talking about first or second or third. And that's if, of course, I guess we need to figure out the other. because it's possible you might not place. All right, there is a probability of 1/20th. You know, it probably would be a lot easier if we went to decimal. So 1/20th as a decimal is 0.05. 1/10th as a decimal is 0.10. 1/4 as a decimal is 0.25. Now that is 5 and 25 is 30 plus 10 is 40. That's 40%. That means he has a 60% chance of being one of the other guys. Now, if it is 4,500 less the 1,000 it costs to get in, that's 3,500. Second place is 3,500 less the 1,000 to get in, that's 2,500. Third place is 1,500 less the 1,000 to get in, that's 500. And then here, you're going to lose your $1,000. And so we're going to put all those together and see what happens. All right, so what we've got here are these numbers when I multiply down, and then I'm going to add across. And when I add the 4 of them together, these add up to 550. Minus 600 leaves me with $50 in the hole. So is it worthwhile? Probably not. This tells me that I am more likely to lose money than win money. Well, I mean, look at it this way. 60% chance that you're not going to win anything. And you're going to lose your $1,000 that it costs to go in. Okay, 2 more to go. All right, 35% chance you'll lose, 40% chance you'll break even, 25% you will make. So lose, even, make money. 35% chance you'll lose, 40% chance you'll break even, 25% chance you'll make money. Now this would be losing 30,000, 0 here, and then making 55,000. And then a quarter of that would be 27.5, would be 13,750. 27.5, yeah. All right, so when we add these together, we actually come out to the good by about 3,250. And so, yeah, this is a good bet. You know, obviously it becomes a question of, can you stand to lose 30,000? But, you know, all things being equal, this would be a good game to play. All right, 2,000 people will attend if it does not rain, 700 people if it does rain. Let's determine the number of expected people. All right, so we're talking about not rain and rain. And there is a 60% chance of rain that day, which means there is a 40% chance of not rain. If it does not rain, we're expecting 2,000. If it does rain, we're expecting 700. So we could project that and that, and added together, they become 1120. So with the weather as it is, you're predicting 1,120 people will show. And that is the end of the worksheet.